Okay guys, let's begin the discussion over the questions. First question is that there are 100 identical coins, each with probability small p of showing heads. They are tossed once. If p is lying between 0 and 1 and the probability of heads showing up on 50 coins is equal to that of heads showing on 51 coins, then the value of p is what? So here, if I take x equals to the number of coins showing heads, because that's what is given in the question. If I take this to be the number of coins showing heads, then probability of x equals 50 is same as probability of x equals 51. And there are how many trials? I can say one coin is tossed 100 times or 100 identical coins are tossed. It's the same thing. So there are 100 trials. So I'm going to say 100C50, p to the power 50, q to the power 100 minus 50, but q is nothing but 1 minus p to the power 100 minus 50, which is 50. This is equal to 100C51, p to the power 51, 1 minus p to the power 100 minus 51, which is 49. Now, if these two are equal, what is the value of p is what the question is asking. So, I am going to say 100C50 upon 100C51 is equal to p to the power 51, 1 minus p to the power 49 whole upon p to the power 50, 1 minus p to the power 50. So, you basically get from here, this is 100 factorial upon 50 factorial into 50 factorial, right? And what is this? 100 factorial upon 51 factorial into 49 factorial, right? This is coming out to be equal to p upon 1 minus p. So this becomes what? This gets cancelled out. You're left with 51 into 50 factorial, which gets cancelled. So you just have 51. Here you have 50 into 49 factorial, which gets cancelled. So you have 50. This is equal to p upon 1 minus p. So you have 51 minus 51p equals 50p, right? So you have 51 equals 50 plus 51, which is 101. P or p is 51 upon 101. P's value is 51 upon 101. Clear? Let's look at the next question. Suppose x follows a binomial distribution with parameters n and p, where p is between 0 and 1. Obviously, if p is between 0 and 1, q, which is nothing but 1 minus p, is also between 0 and 1. That's obvious. That is the probability of failure. If probability of x equals r upon probability of x equals n minus r is independent of n for every value of r, then p is what? Now see, over here, probability of x equals r upon probability of x equals n minus r needs to be considered. This becomes what? So, this is NCR, p to the power r, q, which is 1 minus p to the power n minus r, whole upon NC n minus r, p to the power n minus r, 1 minus p to the power n minus n plus r, which is r. Clear? Now, NCR upon NC n minus r, this is nothing but 1 only. This becomes 1 minus p to the power n minus r whole upon p to the power n minus r minus r. So, this becomes 1 minus p upon p whole to the power n minus 2r, or I can say 1 by p minus 1 whole to the power n minus 2r. Now, you know that this term is positive. Why? Because p is less than 1. So, 1 by p is greater than 1. So, 1 by p minus 1 is greater than 0. If this term is positive and it is given that it is independent of n, very clearly the only thing that can be possible is, if it is positive and independent of n, that means it is equal to 1. If it is equal to 1, this means 1 by p is 2, or p is 1 by 2. So it is for P equals half that this particular situation holds. Next question we have, let A, B, C be three mutually independent events, then which among the following statements is true? Let's see. A and B union C are independent. To show that, let's consider A intersection B union C. That's what we do. This is what? A intersection B union A intersection C. This is nothing but probability of A intersection B plus probability of A intersection C minus probability of A intersection B intersection C. That is the formula for union. This is probability of A into probability of B because A and B are independent. This is probability of A into probability of C because A and C are independent. And this is probability of A, probability of B, probability of C because A, B, C are mutually independent. From here probability of A comes out common, you are left with probability of B plus probability of C. So understand what is left, minus probability of B into probability of C. But probability of B into probability of C is nothing but probability of B intersection C because B and C are independent, and therefore what you are left with is nothing but probability of B union C. So you have concluded probability of A intersection B union C is probability of A into probability of B union C, and therefore yes, S1 is definitely a true statement. What about A and B intersection C being independent? Okay, let's see. A and B intersection C. This is nothing but A intersection B intersection C. I know they are mutually independent, so this is probability of A, probability of B, probability of C. I can write this as probability of A, and probability of B into probability of C can be written as probability of B intersection C. Why? Because B and C are already independent. So A intersection B intersection C's probability is probability of A into probability of B intersection C. Therefore, this is also true, and therefore both S1 and S2 are true. Next question, let's see, is what if from each of the three boxes containing 3 white, 1 black. Okay, so let's just take a note of this, that boxes are containing which balls of which colors and how many. So I have one box which contains 3 white and 1 black. So 3 white and 1 black. Then there is another box which contains 2 white and 2 black. And then there is another box which contains 1 white and 3 black balls. One ball is drawn at random, then the probability that 2 white and 1 black will be drawn. So one ball is drawn at random from each box. What is the probability that 2 white and 1 black ball will be drawn? Now 2 white and 1 black ball. Obviously I am saying W1 is the event of withdrawing white ball from the first box. W2 is event of withdrawing white ball from the second box. W3 is event of drawing a white ball from the third box. Similarly for black balls I have B1, B2, B3. I want 2 white and 1 black, so I can get W1 and W2 and black, or W1 then black from the second, white from the third, or black from the first and white from the second and white from the third. Right? This is the actual event of getting 2 white and 1 black balls when you are withdrawing 1 ball from each box. Right? What is the probability of this event? They are all mutually exclusive, and therefore this is probability of this plus probability of this plus probability of this. Right? Now again they are independent events, so this will be probability of W1 into probability of W2 into probability of B3. What is probability of W1? Probability of W1 is 3 by 4. Probability of W2 is 2 by 4. And probability of B3 is 3 by 4. Plus, then you have probability of W1 again it is 3 by 4. into B2, this is 2 by 4, into, then this is W3, which is 1 by 4. In the end you have B1, which is 1 by 4, then you have W2, which is 2 by 4, and then you have W3, which is 1 by 4. You evaluate this sum and that gives you the probability, which is equal to 13 by 32. Clear? Pretty easy question. Let's move on to the next. We have an experiment has 10 equally likely outcomes. Let A and B be two non-empty events of the experiment. If A consists of 4 outcomes, then number of outcomes that B must have so that A and B are independent. It's already given to you that A and B are independent events. Right? That's what we need to keep into consideration. So it's given to you that probability of A intersection B is probability of A into probability of B. Now probability of A intersection B is number of elements favorable to A intersection B upon total number of events. So total number is 10. Probability of A is number of elements favorable to A upon 10, and same way this is this. Number of elements favorable to A are given to be 4. So this becomes A intersection B whole upon 10 equals 4 upon 10 into NB upon 10. Now from here you basically get that 10 times N of A intersection B equals 4 times NB, or you can say 5 times N of A intersection B equals 2 times NB, which very clearly is suggesting that 5 divides NB. If 5 is dividing NB and the number can be ranging from 1 to 10, right, because these are the total number of outcomes. Clearly NB can be either 5 or 10, right? So NB can be either 5 or it can be 10. Fine. Next, for two events A and B, if probability of A is probability of A by B, which is 1 by 4, and probability of B by A is 1 by 2. Now see, what is given to you here is, try to understand indirect given thing. If probability of A is probability of A by B, that means A and B are independent. Yes, that's what is given to you. Happening of B is not affecting the probability of happening of A. Now you need to show whether A and B are independent or not. You are given that probability of A is same as probability of A by B. This is equal to probability of A intersection B upon probability of B, right? And therefore you are getting probability of A into probability of B is probability of A intersection B. That's what you're getting. And therefore yes, A and B are definitely independent events. Then you have A and B are mutually exclusive. So for this, if you talk about probability of A intersection B, I can write this as probability of A into probability of B by A. We've done this multiplication theorems on probability. Probability of A is what? Probability of A is given as 1 by 4 and probability of B by A is given as 1 by 2. So this becomes 1 by 8, obviously not equal to 0. If probability of A intersection B is not equal to 0, this means A intersection B is not equal to phi, which means A and B are not mutually exclusive. What is the probability of A dash by B? Okay, so probability of A dash by B. Now you know, if A and B are independent, A dash and B are independent, B dash and A are independent, A dash and B dash are independent. So if A dash and B are independent, happening of B is not going to affect the probability of A dash. So this will be 1 minus probability of A, which is 1 minus 1 by 4, which is 3 by 4. So probability of happening of A dash when B has already happened is going to be 3 by 4. Similarly, what is probability of B dash by A dash? Now if A and B are independent, B dash and A dash are independent. So probability of B dash by A dash is same as probability of B dash, which is 1 minus probability of B, which is 1 minus what is probability of B? Now if A and B are independent, probability of B is same as probability of B when A has already happened, which is equal to 1 by 2. So this is 1 by 2. And therefore even this is true. Clear? Let's move on to the next question we have. If A and B are two independent events such that probability of A dash by B is 2 by 15, it's A dash intersection B is 2 by 15, A intersection B dash is 1 by 6, then probability of B is what? Let's see. Okay. Now over here, probability of A dash intersection B. It's given that A and B are independent, so A dash and B are also independent. I can write this as probability of A dash into probability of B, which is 1 minus probability of A into probability of B. No problem. Then it is given that probability of A intersection B dash. This is again, these two are independent events. So this is probability of A into probability of B dash, which is equal to what? Probability of A into 1 minus probability of B. Let me name this as 1 and this as 2. When I talk about 1 minus 2, I know 1 is 2 by 15, 2 is 1 by 6. So this is 2 by 15 minus 1 by 6 is actually probability of B minus PA PB minus PA plus PA PB. Right? That's what it is. So this gets cancelled. You have PA minus PB is 1 by 30. From here you get minus 1 by 30. This is PB minus PA. So PA minus PB will be 1 by 30, or PA is equal to 1 by 30 plus PB. When you substitute this into what do you get here? You get probability of A intersection B dash, which is given as 1 by 6. What do you get? 1 by 6 is equal to probability of A, which is probability of B, plus 1 by 30 into 1 minus probability of B. When you resolve this, you get a quadratic equation in probability of B, and therefore when you solve it, you get two roots of probability of that basically equation, that those roots are nothing but the values of probability of B, because the quadratic equation is in probability of B. So you get two roots which are the values of probability of B, and they are 1 by 6 and 4 by 5. Very easily you can obtain that. Fine. Moving on to the next, we have a random variable x follows a binomial distribution with mean A and variance B. Okay. So the mean is A, that means A is NP and B is NPQ. That is the variance. Then you need to talk about these points being true or false. Now see, you know P, Q both are between 0 and 1. They are probabilities of success and failure. If Q is like this, then if you multiply throughout by NP, N is positive, P is positive. So you get 0 is less than NPQ is less than NP. This is nothing but B and this is nothing but A. So you are getting A is greater than B is greater than 0. A is greater than B is greater than 0. Or I can also say A by B is greater than 1. Right? So this is also true. Then it says A square upon A minus B. Let's talk about that. A square upon A minus B. If I talk about A square upon A minus B, A is NP. So A square is N square P square upon A minus B. Right? So this becomes NP, N square P square, NP common, 1 minus Q. So 1 NP cancels, you have NP upon 1 minus Q, but 1 minus Q is nothing but P, because P plus Q is 1. So you get N, which is definitely an integer. So yes, A square upon A minus B is an integer, and therefore this is not an integer. So the correct options are A, B and C. Moving on to the next, we have a box B1 contains one white ball 3 red balls. So let's just try to incorporate this setup nicely. What is it that we have? There is a box B1, then there is a box B2, and there is this B3. 1 white, 3 red, 2 black. 1 white, 3 red and 2 black. Then it has 2 white, 3 red, 4 black. 2 white, 3 red, 4 black, and then it has 3 white, 4 red, 5 black. 3 white, 4 red, 5 black. If one ball is drawn from each of the boxes, what is the probability that all 3 drawn balls are of the same color? So it can happen that when you withdraw one ball from each box, you get white from the first and white from the second and white from the third, or you get red from the first and red from the second and red from the third, or black from the first and black from the second and black from the third. So this event union this event union this event is the actual event whose probability we need to find. They are mutually exclusive, so the end result will be probability of this plus probability of this plus probability of this. And now these are independent events, so it will be probability of W1 into probability of W2 into probability of W3 plus product of these probabilities plus product of these probabilities. What is probability of W1? It is 1 by 6. Probability of W2, so it is 2 by 9. And probability of W3 is 3 by 12. Fine. Again R1, so it is 3 by 6. Red ball from the second box is 3 by 9. And red ball from the third box is 4 by 12. Then black ball from the first box is 2 by 6. Black ball from the second is 4 by 9. Black ball from the third is 5 by 12. When you add all of this, you basically get 82 by 648 as your answer. Clear? That is what happens to be the probability of obtaining balls of the same color, either all white or all red or all black. Fine? Next question says that if 2 balls are drawn, so in the same setup, now it is saying that what if 2 balls are drawn without replacement from this random selected box, and one of the balls is white and the other ball is red. So the outcome is known, one ball is white and the other ball is red. The probability that these 2 balls are drawn from box 2. Now this is very nice. This, if you define E1, E2, E3 as selecting box 1, then selecting box 2, selecting box 3. It is the event of selecting box 1, event of selecting box 2 and event of selecting box 3. What is probability of E1? It is 1 by 3. They are equally likely outcomes, which is same as probability of E2, which is same as probability of E3. Now I am saying let event A be that the 2 balls, out of the 2 balls, one ball drawn is white and the other ball drawn is red. So I am saying A is the event of drawing one white and one red ball. So let's understand the probability that one white and one red ball was drawn from the first box. One white and one red ball was drawn from the first box. See, out of the 6 available balls in box 1, 2 balls need to be selected. So that can be done in 6C2 ways. I want one white and one red. One white and one red. So 1 into 3 upon 6C2 is the probability that one white and one red ball was drawn from box 1. Then similarly, one white and one red ball was drawn from box 2. Total there are 9 balls. So out of 9, 2 balls we can select in these many ways. Then one white and one red. So 2 into 3. Similarly, probability of A by E3 will be what? How many total balls are there? 12. Out of 12, 2 balls can be selected in 12C2 ways. After this, I want one white and one red. So this is 3 into 4. What is the probability that one white and one red ball was drawn from box 2? We are talking about the Bayes rule. Talking about the Bayes rule, I am interested in the probability of this event. Probability that one white and one red ball was selected from box 2. What is this? This is probability of E2 into probability of A by E2 whole upon probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2 plus probability of E3 into probability of A by E3. Right? The moment you have got this, you know all these individual values. When you plug in all the values, you basically get the probability of happening of event A when, or happening of event E2 when event A has already happened, or I can say probability of withdrawing one white and one red ball from box 2, and that comes out to be 55 by 181. Clear? So revise all these questions very nicely, practice them with utmost concentration. That's it from my side. Thank you.